Okay, what I'd like to show you is how to verify your beam model. This can be done in mainly two ways. The first one is plotting your endpoint and tracking them in 2D plane, and the other is to actually use animation. So I'd like to give you the example how this can be done. So if you open your 20sim model, so let's say this is the beam model you have made. And then first thing you have to do is you have to define your boundary conditions for testing. So in this test, I use my beam, which is modeled in this way. And the boundary condition for testing is fix this A point. So this is fixed point and freely rotating. And then I will apply some torque, which is so then this beam will slowly start rotating and accelerating into some angular velocity. So then the ideal track of this endpoint will be the circle, of course. So this has to be shown in the graph so that you know that your system is working. So so this beam has actually 3 points of interfaces. This is one end, which is fixed. So I put the flow source, y and x, which will be set to be 0. And then I apply some torque. On the other end, we have this, it's free end. So actually I just put this F4 source, which is set to be 0. And this is the point for spring connection. And this will be also set to be 0, F4, so that you have no force on by the spring. The only external force acting on this beam is this moment or torque on this end, from this end. Okay. Then then we have to make sure this is something that runs. So this is compiled okay. So I said I will show two methods. So the first method is to plot the motion of the endpoint beam 1 in XY plane. So by default, this plot, the default plot, has x-axis and y-axis, and x-axis defined to be your time in simulation, and y-axis the interested variable. So what you can do to make the 2D plot of x and y, so you can change your x-axis variable, which is originally time, to your position of this end of the beam. And in my model, it is described as x2 local. So I can just use that as x value. And I can use y value, which is x2y local. Okay, yes. So I have defined the xy variables. Okay, then let me check my initial parameters. So they are all quite wrong actually now. So I'll give you some kind of arbitrary values. So this is mass moment of inertia, length of the beam, the position of the spring from the origin, and this is mass of the beam. And I need to also set the initial value, which is the theta 0, which is the initial angle of the beam. So 0 being this beam in vertical position. So I don't have to change that. Okay. Having done it, then I'll just run simulation and see. So if it is in right scale, you will see circle motion of this the end of the beam. So it starts from here, and then it'll probably rotate this way, on and on. And so this tells me that I have right kinematic connections, and this behaves in a proper way. And I can try to animate this also. So I can use 3D animation. So I'll use a beam element, line element, to describe my beam. So you can just double click this 3D animation plot, and you have this. You can set your cameras from here, how it looks on your screen, and I'll have to put some elements to describe the motion. So what I will do is I will, on the scenery, right click, insert line, and I'll describe it as a cylinder. And how you define your line here is you define it by specifying your start position and end position. And start position is at the origin, so it's X position, Y position. These are defined by value 0, 0, 0. That's okay. But end value will change, so that is Z position should be 0, by the way. And X position is defined as your position of the X position of this end of the beam in X-axis. So that's described as X position, X2 local, okay. And the Y position is defined as Y2 position, Y2 local here. That's the variable that I use to represent the position. And this is calculated from the Q sensor in the beam one. Okay, so actually that's it. Actually, simple. You see now I have beam in the space, so it's better to have a look at this from the top camera. So in the default lights and cameras, just go down to this top camera, front camera, XY, because it's XY. So if I just click this, then I'll see it from the top. Actually, it says front, but it's kind of top. Okay. Actually, I have run the calculation or simulation, so it's already, the positions are already simulated. Or I can just do one more time, reset the simulation, just run it, and then see what happens. And so this, and then you can replay in real time by playing this using. So this starts rotating, and then it start accelerating because I'm applying continuous torque, and the simulation came to an end. Yeah, so you see that the beam didn't change its length while it's moving in the space. So that means I have correct kinematic relationship, and it's accelerating, so it's as expected. So that's the method you can effectively use to verify that your beam model is right. You can extend this to when you have another beam model, when you connect another beam model here. Say I have connected them. Then you can add another beam, the line, go to scenery and insert one more line. Then what you can do is you can set your start position as your the first point of the beam, of the added beam on the left, and end the position as the other side of the position of the other side of point. So then you need to calculate your absolute position from the origin, which is the fixed end of the beam one. And this you need to have some kind of routine somewhere in the Q sensor or external block where you calculate your absolute position of the beam, the point in AB in the beam to specify start position and end position. And if you have done it right, then you should see your line as it is aligned with this beam. So for example, if you have done it right, then the cylinder should appear vertical for the second beam, and the 2 points, the end points should be at the same point for all simulations. If they are departing somehow, then that means there are some errors in your connections. So make sure that, so this is how you can verify even bigger models, and same follows for the last part. Okay, that's the end of my advice for verification of your model.